Welcome to Revolutions, the show that takes an in-depth look at the gear industry. My name's Matt Jaster. I'm senior editor at Gear Technology Magazine, and I'm joined today by Doug Beerck from Gleason. Welcome, Doug.
Thank you, Matt.
We're going to talk about laser scanning today. So tell me how laser scanning is making it easier to support gear development today.
We're doing that in a lot of ways this year, Matt. We have introduced over the last couple of years at these shows a variety of non-contact scanning products. The GMSL was introduced at this show. The GRSL gear rolling system with scanner was introduced at this show. And this year we're introducing a fully automated robot-loaded GRSL with complete analytical and functional capability, as well as a couple different noise analysis products for gear noise analysis that is benefiting from the ability to laser scan.
How does this process expand both the functionality and the range of applications?
The functionality gains with non-contact scanning are primarily accuracy repeatability gains. You're taking a larger data sample, and a productivity gain in that you're taking that data sample at a much faster rate. So the productivity gains lend itself to the ability to do more when you can do it in a reasonable amount of time. So there are more tools you can use software-wise, there are more tools you can use analysis-wise when you have additional data to analyze of a full flank form scan.
Okay. What kind of materials can be inspected on something like the 300 GMSL?
The materials side of things have gotten a lot better with lasers in general. A lot of the filtering capability of the laser sensors of today are much better than they were a few years ago. On our machine platform, we use that capability well, and most materials work well for laser scanning. The exception maybe being an opaque, lighter, clear type of plastic gear where the surface is hard to identify for the laser, or maybe a very fine pitch, high helix gear where the laser cannot access everything in such a small space. But with a multi-sensor GMSL product, the combination of tactile probing and laser probing allows the switch automatic change to a tactile probe to access some of those features the laser cannot access.
Okay. How about describing some of the additional benefits that come with laser scanning gears today?
Well, the laser scanning, again, with the higher density sample, has added a lot of capability for software tools such as noise analysis and surface mapping and things like that, where the full flank form scan is needed to evaluate gear noise conditions, surface conditions of the gear that could add to premature failure and things like that earlier in the manufacturing process before any assembly is done. It adds extraordinary value for the gear manufacturer.
And how do you think the inspection process will evolve in the future?
Well, I think it's already evolving at Gleason. We have been in the forefront of non-contact gear inspection for quite some time, and our customers and prospective customers are coming to us more and more, and they're asking for not only flank form scanning using a non-contact laser, but full closed-loop corrections data, working with the machine tool to use that data to make in-process changes to the machine tool settings, and also with Gleason's KissOff design software to allow for changes back to the design of the gear itself. The lights out factory is coming, and I think it's an exciting time for the industry, an exciting time for Gleason.
All right. Well, thanks for joining us today, Doug.
You're welcome, Matt. Thank you for having me. Thank you.